a storm chaser since 2000, and it's amazing to see how it's changed over the years. Basically, back then, we would track storms from, seeing them in the distance to using AM radio to zero in on the storms. It might be crackling in London more, and then or Kitchener, and if we couldn't see them because of overcast, that's how we'd zero in on them. And then 2009 came along, and we got portable internet, and now basically that was through laptop, and now we do everything by cell phone. You can basically do all the information we need on it. So this program will have a wide variety of weather, but of course, I got to start with some sort of storm aspect, being a storm chaser. And that is, we're going to look at gust fronts and shelf clouds here. And basically, this is your leading edge of the thunderstorm. And it's generally where you're going to have the worst straight line winds in it. So as you can see here with this one, this is a time lapse. And you can see the layering of the shelf at the top here. And then at the base here, you'll see it get rougher as it gets closer. That's your gust front. That's really where your warm air is meeting the cold air. And that's where you get that kind of rough look. It's right where that warm air is in front of the storm, warm, moist air, and then you have that cold rain and hail potentially coming down out of the thunderstorm that gust out front and then create that feature right on the front aspect there. So, I think we have an animal that's not too happy there. But anyways, you can see we have the rain now coming in here, and we also have a truck coming at us. So it's moving about 50, 60 kilometers an hour there. But what you'll see here is that we get into the thunderstorm more, the winds continue to intensify. And this is actually what you would call a microburst. So what's happening is the whole storm is basically collapsing. And you can see it's almost like a whiteout in a sense. That silo you were looking at in the background there is basically not visible anymore. And therefore, it's your kind of your classic microburst look. Very strong winds. We're around about 100 kilometers an hour. We switch gears here a bit. You can see a bit of snow on the ground there. And then you can actually see this funnel cloud in the center there. Now, this was taken December 12th, 2017. And we are actually one of the few areas that can see snowspouts. One of the most famous snowspout photos is actually from Lake Ontario, south of Whitby there. So it's pretty neat in its sense as well. It was one of the earliest photographs of them. So what you need is a very drastic temperature difference. So even though the lake is only maybe about 3 degrees Celsius at this time of year, the difference between the water temperature and the 850 millibar level, which is also 1,500 meters, also 5,000 feet, that difference, if it's greater than 13 degrees, you can get these towering clouds that converge in one area and kind of go up the lake like a line. And when you see that taking place, that is generally where you can get these little, well, they can be large, but these snowspouts that will form, or water spouts even. And we're going to go into the more traditional aspect of what we see, and that is our water spouts. And so right here, you had a small funnel a little earlier there. It's kind of in the distance here. We'll take a look at a better one here, but here's that kind of example of a convergence line. And these clouds are lifting above. And as they lift, what happens is you get this thermal that forms on the water. And because of that temperature difference, it's drawn upwards. And then as it connects with the base of the cloud, it actually basically starts to rotate. So here we are over the city, where you can actually see it rotating right in the center of your screen there. Now, that's because the marine layer can actually move inland. So even though that part of the cloud is not under or above water, it's basically giving you that same effect because the marine layer shifted inland. The southwest winds had brought it in towards Buffalo. But here's an example of a spray ring. You can see it now in the center of your screen. And then as that spray ring tightens up, you then get a condensation funnel above it here. And there's your condensation funnel. So we basically have a water spout at this point now. And so one of the interesting things about this one was the fact that we weren't quite sure if it was going to go into Buffalo or not. You can actually see it moving towards the city. But as it did move towards the city, it actually then basically got closer and closer to it, but weakened at the same time. And but you can still see the spray ring at the bottom there. as it does push closer. And so it was an interesting part to the to that water spout is, was it going to make it inland? And some do actually make it inland. And what they do is they actually they only usually go in about 500 meters to basically a kilometer when they do go in. So that gives you an idea on kind of water spouts and snow spouts. And now we're going to take a look at lake effect. Fortunately, you guys live in a great area for not seeing a lot of lake effect snow. For example, even I do too here in the Niagara region. And you can see this kind of squall moving from west to east. And basically, I'm south Vineland at this point, so about 7 kilometers from the shoreline. I'm barely seeing snowflakes, whereas the north side of Vineland is probably seeing about 5 to 7 centimeters at that point. So lake effect tends to be really localized. And so, for example, you can see this kind of line of cloud in the distance there. Well, I then moved closer to be underneath it, and this is what it looked like. I called it the wall of squall, basically. And it's channeling right up, and it's going, of course, to Buffalo, because as they say, if there's weather coming through the area, Buffalo is going to get hit from one angle or another. So as you can see, I time-lapsed it again so you can kind of see the entire process basically take place here, where the snow is falling, and it was gradually moving from basically south to north. So eventually I ended up in it as well too. And so as you get underneath the squall, some of the times you actually end up with basically very calm conditions, because a lot of the times the winds are converging from the south and the north, whereas this is more of your snow squall event that comes in with a cold front. And you can see a much different scenario with it, just rapid wind, all that type of thing. So as it went that way, you can actually see the intensity with it. But these snow squalls tend to not last as long. They actually usually only last maybe an hour and a half, and then eventually you can see here they're clearing out afterwards as well too. So this is on the QEW here. You can see kind of the nice evening light behind, and then the snow squall basically pushing right through. And as you can see, it leads to a more beautiful scene, kind of adds some warm tones to what's going to be a very, very cold night. So that's more your cold front snow squall, basically something that pushes through, whereas lake effect can set up and hit the same area for hours on end. Now, something you may see along Lake Ontario in your area is ice mounds or ice caves, or in this case, an ice bridge. And these things are really interesting to see because, and how they form is, generally you get a thin layer of ice on the lake, or sometimes you get these like little ice balls as well that form, and then they get, when a windstorm comes in, they push them into a mound along the shoreline, and that cycle keeps happening over and over again. So as that cycle happens over and over again, you get these mounds, but then what happens is if you get a big windstorm that comes, it'll come and it starts to carve away at these mounds. So sometimes you end up with an ice cave, sometimes you end up with an ice bridge like this one here where you can see right through it. And then there are times where you don't know it's there. And if sometimes people are walking on top of them, they actually fall right through because it's been hollowed out by the waves. That's why I always say it's better to stay on land where you know everything's okay and admire them from a distance there. But you can really see how this was taking place here. And it's got the icicles, and that's, again, waves from the past that have hit the kind of the roof of the bridge and then came kind of dripped in that downward, creating these beautiful icicles. Now, something you can enjoy if you're bundled up, and that is Arctic sea smoke. And this, again, forms on Lake Ontario quite a bit. And you live on what I call the better side of the lake for this type of thing because of the fact that, especially around sunrise, the sun shines through it and it kind of acts like an X-ray. And I'll show you why that's really neat in a moment here with something else. But here it is here. So what is Arctic sea smoke? Well, Arctic sea smoke is basically, you have a warm body of water and then you have extremely cold air above. So it's about minus 17 on this morning, and I've seen it at minus 22, which is even more spectacular yet. And that is where basically that warm water is evaporating right into that cold air, and it condenses into that, what they would call Arctic sea smoke, which is a super cooled water vapor. So it still may be in a water form. Some of it does turn to crystal relatively quickly, but there's still super cooled water vapor in the air. And what's neat about super cooled water vapor is the fact that even at -40, it can still stay a gaseous state of vapor, basically. So that is one of the neat things when it comes to that, because when you look up at the clouds, yeah, there's ice crystals and stuff like that, but in the winter, if it didn't stay super cooled, then you would have no cloud because it would just be down at the surface, or you just have all crystal and then you wouldn't get much precipitation. So it's really neat in that aspect on how water works. And in this case, the only thing warm about that day was the fact that there was the sunrise. It was very cold, but the warm tones made it, or at least made it look warmer than it really was. And you can see this cloud over the lake here. And what's really neat about that is the fact that on the east or west end, we're not seeing snow. If you go to Rochester and the other end of Lake Ontario, at the east end there, you basically have, you could be getting snowfall rates of anywhere from 15 to 30 centimeters every 6 hours, if not more at times too. So we're going to take a look at it. You can see Arctic sea smoke even in late summer and the fall. You just don't think of the Arctic then, but it's basically that kind of mist and fog coming off the water there. And, but this is why I like having the sun shine through it. See how that looks like basically a small tornado? Well, they're called steam devils. And I've actually had some come ashore and pass through me, and they barely even have a breeze to them, but they're really neat to see because they have the same mechanics as tornadoes do. And this one here, you can see right over this spring-fed water area where basically the water of the ground is warmer than the air around it. So that's why you get this, that Arctic sea smoke over it. And I don't know how many of you have been to Niagara Falls during the winter, but it is spectacular at any time of year, really. But if you ever time it and you have it where it's a cold snap, you not only get ice in the trees, but you can get it where you get the kind of mist or the Arctic sea smoke going all the way down the river. So it adds an amazing depth to it and really creates that winter wonderland with a little extra atmosphere to it. So we're all used to this mist that rises off the falls. Usually you can see it in the summer even, but in times where it's extremely cold like this was -23, you can actually see there's more of it yet. So there it is there right down the river basically, and it adds such a neat depth to it, and especially when you can see there's often ducks and other birds around there too that will through it as well. So it really does add kind of a whole neat element to it. So we slightly warm things up a bit here, then we do a little bit more winter, and then I really warm things up after that. So typical first frost, we just had our first frost here on November 1st, and actually had snow the day before. But overall, you know, usually September, October is when everyone has their first frost in Ontario. But there you can see this kind of coloration in a shape of an arc or a bow. So you can kind of see a sparkling there. Well, that's actually a frost dog or a sun dog, but it's on the ground. I will show you examples later on, though, of them across snow, because you can actually see the reds in the color as well too. And so at this time of year, generally the river water is still warmer than the air, so you often get the heavier frost around any river area or even in the little valley area, because again, it's that kind of Arctic sea smoke effect to it. So I'm going to show you elevation. And this tree here, you got a bit of snow on it, and these trees have snow on it because they're protected from the wind on the escarpment. Well, I go up another 100 feet on the escarpment in the next scene here, and you'll actually get to see where it's a frosty wonderland. So altitude actually really does change our temperature, and the escarpment and living by the lake, like both in Whitby as well as where I live in Beamsville, it really does allow us to have more moderation. And so, for example, the weather nerd in me has to know these things. And basically what I'll do is on a lunch break, I went down to the lake and it's been, for example, +2. Then I go halfway up the escarpment, it's +1 and it's raining. Then if I get to the top of the escarpment, it's often a snow and rain mix or a complete snow fall at that point. And then I go back down the escarpment and it's back to rain. And basically I'll do that up. And December is one of the best times for that sort of thing. But I just like to see how, again, altitude really does affect your the changing in temperature. And so I'll cover a bit more of that in this frosty part of things as well too. So that's more of a typical frost. There you have the northern lights in the background. There's a little bit of sparkle on the ground from a ground frost. There's that super cool water vapor in the background. Basically, as it goes over an area over and over and over again, it just keeps layering up. So for example, if you've ever been in the mountains before, at that 5,000 foot level or even a bit below, cloud can generally form even at 100 at the kilometer mark as well. So when you have that and it keeps going over the same area, it coats the trees in these tremendous layers of kind of frosty snow, similar to what you're seeing here. But it can actually be, I've seen it as much as 3 to 4 inches, or in this case, 7.5 to 10 centimeters. And so that it's kind of like this basically. So you can see this even at our level as well. If you were north of Whitby, for example, and you have a fog that forms at night, or like you're seeing here, and if it keeps coating that same area over and over again, it will leave that type of coating on it. And generally what you need is calm, still conditions the night before. And even if you have snow on the ground and it gets just above freezing the day before, it adds a little bit more yet to it as well. So that is one of the things that I will look for, and I'll time in weather to try to be out there and get scenes like what you're seeing right here as well too. And as it warms up, it's amazing to watch how basically temperature can knock the frost off the trees, or it can even be just a little bit of a breeze. And I find that's about an hour and a half after the sun has come up that it starts to become that and starts to fall off the trees. But until then, you get these really beautiful frosty kind of light bulb scenes, and then there's the example of it starting to fall off as these little flakes and that. So here's that ground sundog I was telling you about. So these are usually at 20, 30, 40,000 feet up in the atmosphere, whereas you can see here, these are right along the surface from the left side of your screen, and there's one on the right side of your screen there as well too. And on extremely cold mornings, you can actually get it that the ice crystals falling through the air in front of you. And these ones are maybe only about 60 feet or 20 meters away from me. And it's so neat to see them, because what you're seeing is basically the atmosphere down at your level. And that was minus 33 to accomplish that. It doesn't have to necessarily be that. You just need the right combination of ice crystals in the air. But I do remember that morning very well because of how cold it was. And that was back when you had to use AA batteries for your camera, and I had to take a picture or two, and then the batteries would die, and I'd warm them back up in my hands and then put them back in the camera, and they'd give me another shot or two. Then there's what's called solar halos, or in this case a lunar halo. Now when it comes to the sun, you definitely want to shield your eyes with it, completely block it off. But when it comes to the moon, you can actually enjoy looking at the moon, and with these halos that form around them. And you can see when the heavier cloud moves in, that it starts to obstruct the halo, and that just too much ice crystal, not as well uniformed as well. The crystal's getting heavier in some areas and not heavier, which is in others, which is not allowing for that proper refraction to take place. And then there's what's called sun pillars. So this generally is the best when the sun's below the horizon. You can even get them around the moon as well, like this one here. And that is often anywhere from, you can have it at any time, but it's that, again, that ice crystal falling through the air. And this is something I know you can see in the Whitby area, especially in the north of there, is light pillars. And these are, again, basically what's causing the sun pillars. Well, these are falling right to the surface, and all these streets are following these, reflecting off these ice crystals, and it's refracting back up into space. It's really tremendous to see. So during the Christmas ice storm, I got some of these pillars. You can see the ice on the tree, and then this is a time lapse. You can actually see the plumes of moisture going through the air, ice crystal in this case, and how it gets heavier and weaker. Well, in this case, sometimes you see the stars, but it was so heavy that night you couldn't even see them. So that gives you an idea there. And this is something you might see. This is from my backyard, actually, in Beamsville. But because we live so close to the lake, it often moderates the lowest levels. And so you need that ice crystal to be falling. And sometimes they don't right down to the surface. But if you ever look up and you see kind of columns up there, it's a good chance that it is light pillars. And now we warm things up. So now we're going to warm things up to what are called crepuscular rays. And if some of you or many of you have probably been driving down the road before, and on those foggy or misty mornings, you get to see these beautiful rays through the trees, as well as walking through the woods is a great way to enjoy them. If you've had a rain the night before, or there's a fog that was in the area and it starts to dissipate, you can see here how they can change over time. So this is a 12-minute time lapse into 12 seconds. And you can actually see how the rays disappeared and then they got stronger again. So different changing in the moisture will actually cause that to take place too. And another thing that we get to enjoy around Lake Ontario is something called fog bows. So here's a fog bow here, and you can see it doesn't have the coloration like a rainbow does, and that's because of the fact that the droplets are so small. They're actually a lot tinier than a raindrop. So what you get is this real kind of white, brilliant bow, and sometimes you can even get a second one inside of it as well too. And but then there's times where the fog is just too heavy and the sun can't get through. But this is a great time of year to potentially see them. And you can actually see them even in the country as well too, especially in the morning. And that can be any time of year. Even in the winter, I've seen them with that super cool water vapor that I was telling you about earlier. It can still be happening then too. So another thing I wanted to show you is something that's called a glory. So how do we get a glory? Because usually you have to be in an airplane or on a mountain to see it. Well, because we live in a province that has the escarpment, you can actually get to see that here as well too. First, I'll show you some of the process. So here we have air hitting this fog and kind of rolling it up. So that was pretty neat in itself too, because they look like waves going by in this time lapse. But what I was really there for was the fact it was around noon. It was between 12 and 1 o'clock in the afternoon. So I knew the sun would be higher, and with the fog below me, I could possibly get this coloration around me. So you're going to get to see that. Watch the center of your screen right here, and you'll get to actually see this color start to take place. It's starting to come now. So you can see kind of that orangish and red on the outside of it there. And you'll see my shadow in a moment. So every time I walked around, that followed me. It's just the fact that I had the camera. So when I had the camera, it stayed in one place. So everybody can have their own glory, but these are most commonly seen in airplanes. So if you're ever in a plane and you look out your window and you see kind of your shadow below, there'll often be a color around it if there's a cloud deck that's fairly even below it. So in this case, I used fog to be my even cloud or water droplets below me, and then you could see that glory form there. So now we're going to look at some really weird looking clouds, and this is what people have called it the marshmallow cloud. You can kind of see it's a rolling marshmallow, but it is a roll cloud. And what was weird about this was the time of year that it formed. So this is along Lake Erie, and basically what happened is we had thunderstorms the night before, so it was very warm, moist air for January. And then we had a cold front come through, and there was a layer there that had just enough moisture to roll up like that, and what you were seeing. What was neat is 15 minutes later, look at what's all that's left of it. Not very much was left of it. Fortunately, I did get some pictures with snow on the ground. You can see them there. So there's your roll cloud feature coming in, and then you can see Lake Erie there with the ice on it. So that was my way of proving it did happen at that time of year. And you can see the real beautiful curvature as I look north and that too. So basically, those form with warm air rising on the front side, and then on the back side is where your sinking cold air is. And you're going to see an example of that in the right here. See, this is the back side of one. And you can see it all sinking. This is obviously sped up in the time lapse, but overall you can see that whole kind of process taking hold there. And so if you were flying in a paraglider, the last place you want to be is on the back side of that, because whenever you're flying anything, the last thing you want to feel is sinking air. You want to be on the front of it. And I wouldn't even recommend it in this case, because there's usually a thunderstorm associated with it or somewhere nearby, because these are actually what separate away from the storm. So you can see the storm above here, and then you can actually see this kind of rolling gust front out in front of it. And you can see at times it tries to rise up. Now, this is a pocket of cold air, and storms like warm, moist air, so you could see it expand and shrink, and it would try to pull it in, but it was unable to do so because of the fact that they're just not meant to mix. So again, about 15, 20 minutes later, you can see not much left of that feature anymore. It's basically went soft and almost trying to form new cloud again, because that's what really those roll clouds are, basically pockets of rolling shear, and they try to form new clouds out in front of them. But if it's not enough of a temperature difference, it won't happen. So now we're going to look at fall streak holes. And so what they are, they kind of look like somebody took a hole punch to the cloud. And you'll see some great examples of that, especially at the end. But what the process is again, that super cooled water vapor. You can kind of see this wispiness, and this used to be all cloud here, but it's kind of all fallen away. Not your true fall streak hole, but it is part of the process, which you can see again. Here's some of that wispy aspect to it. So ice crystals falling, super cooled water vapor, all kind of falling away. This is all that's left of one, and so it was a circular area around it. But here's one that doesn't quite look like a fall streak hole, but it is the same process. So it's kind of more like a boat. And but you can see that shape, and it's basically falling away from the cloud there, or the cloud deck. And so after this, you can see the process, but here's the best example. These are at night over Lake Ontario. This is Jordan Harbor, and you can see it really does look like somebody just took a hole punch to the cloud. And these have been actually called in as UFOs before, which in a way, if you look at them, you can kind of understand it, because it does look kind of out-of-worldly, but it's all a natural process, just so that super cooled water vapor falling away from a cloud deck, leaving that hole there to basically that kind of shape to it. So now we move on to northern lights. Northern lights are something we do see in our province, and even at the southern parts. They run on an 11-year solar cycle. So right now we're kind of in the low period, but we are starting to build up to it. So 2024, 2025, we'll be back at the peak. And what does that mean? Well, basically it means that we have more sunspots on the sun. The more sunspots you have, the more likely you are to actually have northern lights, because what happens is these sunspots emit coronal mass ejections and solar flares, but it's the coronal mass ejections that interact with our magnetic field. And when it does that, our magnetic field has two options. It goes north, that shields us from the particles. If it goes south, it lets it into our atmosphere, still not down to ground level, but then that's when we get to see those beautiful colors to the north. And they basically range from a minor storm, from minor to G1 right up to G5, so geomagnetic storm. And if you hear anything about G3 to G5 in the news or anything like that, then that's when you could probably see, potentially, if it's clear, maybe even see them out in your backyard, even with light pollution. There's been a few displays that they've seen in Toronto, regardless of the fact that the light pollution. So here's an example of northern lights. There's Toronto off to the left there, and then dawn here, and then the northern lights above. This was a G3 storm that you were looking at to be that strong. So generally for me to see them down here, I have seen them at G1, but generally G3 is very pleasing to the eyes when they do happen. Now we have a little shear funnel, and this is something I like to have in my show, because it's something you can do if you're just laying out under the clouds or the sunny day, just soaking it in. You can actually watch these little funnel clouds form on these cumulus clouds. So they're fair weather clouds, basically. You get these little kind of heat clouds that are forming around, and then they form these little funnels. So this is what's called a shear funnel. It's a blue sky day, and you can see it kind of just floating there on its own. And it's just a neat way to see kind of the mechanics without having to worry about it touching down. I always still say watch a vortice, because you never know if it'll touch down, whereas this is more of what people are used to seeing, and that is tornadoes. But that's the time to take your shelter. But when you see those little puffy cumulus clouds, and if you ever see a funnel on the bottom of it, it can be pretty neat. And it's just, they usually last maybe 30 to 45 seconds, and then they disappear. So this was a supercell thunderstorm that did produce a tornado in the Grand Valley area. But what was neat about it is it tried to cycle up again by Orangeville, but you can see it's basically getting weaker at this point and elevated. Generally, the lower, the more apt there is a chance of a tornado if there's. But as you can see here, when I speed it up, it collapses. But this was the neatest part about it, was the fact that right in the center here, you can see it rotating. And this storm basically collapsed so fast that we got to see some of the inner vortices inside the once large thunderstorm. And then when it collapsed that quickly, it allowed us just to see kind of what was going on. There's even another one off to the left there will form, but right in the center is the best example. So often with these supercell thunderstorms, they actually have vortices inside of them, but we just don't get to see. That's all. So that's one of the neat things with it. Now, when it comes to rain, and that sometimes we have drought periods and that as well. And in this case, I had to use a hose to get a rainbow, or in this case, even wave spray bows and that too. So you can see those on the shoreline too. You don't even have to go in the water, even near the water, just get a little bit of elevation. And so you can see it hitting this pier. And each time it hits the pier, because the sun's behind me and at just the right angle, it was creating these wave spray bows. And so now we have rainbows. So you saw the fog bow earlier, and now you're getting to see the rainbow. Well, this rainbow here, I was able to predict where it was going to be because, of course, the sun was to my back, and then we had the rainbow to the east, and the shower was going by, and therefore I was able to predict where the rainbow was going to be. Well, you don't always need a rainbow to have a beautiful sky. I also went to the other side of the shower, and you can see these beautiful rain curtains as the sun started to set. So you can pick either side you want. So if you're facing the sun and it's raining between you and the sun, and yet you can see it, you'll get those beautiful colors. If you have the sun at your back and the showers pushing to your east, you'll get this beautiful rainbow to your east as well too. So it's really neat in that aspect when it comes to coloration. Now, as for sunsets and sunrises, but we'll focus on the sunset here. What I often do to be able to tell how long a sunset's going to last and also how vivid the colors are going to be, I will look at the type of cloud. So we have cirrus cloud here, but I will also look to the east. So there's a sunset going on, but I still have beautiful colors to the east as well too. So that gives me a gauge on how long it's going to be and also the types of colors. So generally you start out with kind of a whitish gold, and then you go to kind of a yellow to orange to reddish pink. Those are generally the transitions you'll get with the sunsets. And in the background, you can see my dad laying there, and he's trying to dry the lens at that point. And I'm out kind of on the pier here, but with a big wall between me and the waves as well too. Others go further out. I tend to stay where at least some of the wave is going to be broken because of the wall. But we just had that big November windstorm on Sunday, and winds actually with it were 141 kilometers an hour. They gusted in St. Catharines. Where I was positioned, I was at Crystal Beach, where they hit around 130 kilometers an hour. And this is an example of one from a few years ago, but still it had winds of 109 kilometers an hour. But the waves were about 5 meters in height over the lake. And as they come in, the land starts to rise, so you don't have as much water coming with it, so the waves start to get smaller. But you can see when they crash up, they're basically doubling the cottages that are along the shoreline here. So pretty neat in that sense. Now, what was different about the storm on Sunday was the fact that it was actually forecasted around Long Point to have waves of around 26 feet or around 6 meters, basically. And that is something even experienced storm chasers like myself or others have not seen that high of forecast before. So it was truly a intense and impressive storm, to say the least. And so when it comes to that, you can also get some other weather as well too, and that's when you get mustache clouds. So very similar to the shear funnels that I was showing you earlier, but these actually form more so on these very intense windy days. So you can actually see one rotating in the center there. And then here's more, now you can see more of the mustache style there, but it's maybe unique. Can't say it's the most stylish, definitely unique, but this is basically going right across the sky. And how do these form? Well, let's say you have winds at the surface that are sustained at 60 kilometers an hour. When they are sustained at that, then you go up to that, let's say, 1,500 meter level, so 850 millibar level, and the winds are sustained there at 70 kilometers an hour. What this creates is what's called speed shear. So then you have faster winds above the slower winds, even though both are moving fairly fast, it starts to roll. And there's actually vortices up there all the time. There's just usually not the moisture to condense and show us. But on this day, there was. and you can see kind of that mustache cloud. You can see it tapering off now on the right side of your screen there, and that as it finished off. Well, I drove another couple hundred meters, and that's when I saw this one right in the center of your screen there, and it was rotating. So these are funnel clouds that are just basically forming again on that open blue sky. And I don't know about you, but whenever there's a wind event, it always seems like it strikes on garbage day. And so when this was one of those days where it was garbage day, and I actually got hit with two pieces of debris, the only times I've really been hit by anything. Fortunately, one was just a margarine container, and the other one was just I don't know what it was, but they were both small. And so now we're going to take a look at lightning. This type of lightning is what's called bolt from the blue. And it can strike out of the storm up to 5, 10, some have even been recorded up to 20 kilometers away from the storm. So you can see how it's leaving the whole thunderstorm. So this is a cumulonimbus cloud, or you can call it a thunderhead. That's the easiest, because you'll never hear a storm chaser out there yell, "Oh, look at the cumulonimbus cloud." And but you can see it basically coming right out the back there, and some other neat aspects too, like cloud-to-air lightning. So you can actually see the cloud-to-air lightning, and that is caused by a negative charge inside the cloud, and in the air there's actually a positive charge, and so they just come out. They're very small, and it's basically similar to what's called intra-cloud lightning, like what you're seeing here, where it's just a whole bunch of sparks going off inside the storm. Only thing was we could see the outside of it, and it's striking the air. So here is Northern Lights with lightning at the surface. I thought that was more common, but because I first saw it in my career in 2002, it took me 15 more years to get this over Lake Huron. So I thought, I'm glad I was able to capture it that night, but it's a rare to be able to combine thunderstorms and Northern Lights. This is what's called an anvil crawler, so it's going along the upper parts of the storm, but along the bottom of the upper parts. And then this is cloud-to-cloud lightning. So it's generally going from one storm to another. And this is upward lightning. What's neat about that is it's radio towers, high rises, and other aspects like that often are where you'll see this type of thing get produced. And it's usually a cloud to ground lightning strike that hits off to the side that creates this. So a few split seconds later, you get this upward lightning strike. So I'll show you an example here. So I'll put it into slow motion. And basically, you'll see it right here where you have a cloud-to-ground lightning strike first, and then watch this area, windmills. Windmills will also produce it as well, too, where all the lightning is actually going back upwards. You can see almost like a fork shape to it. So that's one of the neat things that cameras have been able to capture. It was late 1800s when people started to believe that happened. Now with cameras and that, we can confirm that it does happen. What was neat about this one was the fact that usually there's only 1, 2, maybe 3 of them, but because of windmills, and that has nothing to really do with windmills themselves, it's just the energy has more ways to get back up to the sky, and we call these upward lightning clusters because, as you can see, there was about 7 or 8 of them there. This is some of the most spectacular lightning you can see, and it's usually when the storm is actually starting to decay, and that is what's called stratiform lightning. So you can get these that form right on the backside of huge lines, and that too, where the lightning can go on for 400 or 500 kilometers an hour on the back edge of the storm, and it can actually last up to about 5 to 6 seconds. I think the longest it was in France for 7.2 seconds as it traveled all along the backside of the storm. So I was working with Environment Canada to basically confirm lightning strikes for them. So what I would do is record my coordinates, tell them where I was pointing, and then they had software that could visually see the lightning. And that allowed them to, I was able to confirm that for them, and then their software, it was really neat to see how it would capture the lightning and see it. But to give you an idea, this lightning strike here went for 67 kilometers. It started over Lake Ontario, went to Niagara Falls, and then towards the Hamilton direction. So it was really neat to find out officially how long that lightning strike was. There was actually some more of it. It was just that it went over my head as well, too. And here's an example of some more of that stratiform lightning. It can be quite spectacular. There's no stacking of the images here. This is all one shot. And on the backside of these storms, you can get these really neat bulbous clouds, or mammatus is their name, or another name is mamma. And what it is cold, moist or humid sinking air. Usually you have warm, moist air that's going up. Well, these actually go down, and they form right on the backside, or they can be on the front side of the storms, but it's again right on the anvil, which is basically your upper part of the storm. And you can even see them in the fall and summer, or fall and winter with no storm as well. And now for the final part, the inferior mirage and superior mirage. Now, I know you can see mirages from Whitby because I probably look at the other side and the land looks like you're floating in air there. Well, here's an example of that. So an inferior mirage, the best way to describe it is basically one where you're driving down the road and you see what looks like a puddle in the distance on a sunny day. You get there and the puddle's not there. Well, that's because of the fact that the sun's hitting the asphalt, and then it warms it up so quickly and then hits the cold air above, and then you get that layer that forms and it refracts it back to your eyes as the blue sky refracted back to your eyes. So that's one of the neat things with inferior mirages. So that's what we see more so. So inferior means flip down. But in this case, look at Toronto, where it looks like it's a hovering city. You can see the buildings up in the air there. And when they're up in the air like that, it really looks futuristic. Well, those are what are called superior mirages. And some superior mirages form differently. They have large areas of cold air temperatures right at the surface, and the sun can't get down to the surface because it's a lake, and it is hitting the lake, but it's not able to warm it up. So what happens is you get this cold layer that forms for many, many kilometers because Lake Ontario is so equal in temperature. And so you get this boundary that forms. And if the winds are converging right, it'll actually form these layers. And this is more towards even Scarborough and towards your direction. And you can see kind of that hazy layer forming, and things look flipped up. And when I time lapse it, you can see the layer actually move as it tries to mix. Because, of course, warm air is used, or the sun and the warm air is used to going upwards. And in this case, it can't because of that cold body of water. And this is the best to be seen in late winter, spring, and sometimes even early summer when the lake is still quite cool and the air above is quite warm. And here's another version of it, but this is going to be really neat too. So here's the typical one. There's the land. It looks like cloud off in the distance. I will show you where it's not. So again, it's flipped upwards. But I'll show you this. Right there is kind of like a crocodile mouth. That's the escarpment being flipped upside down. So it kind of has that crocodile look. Then you have this Smarty shape of a sun. And watch as I speed it up in a time lapse. Note how it's not coming up. And you can see it just kind of sliding there. And then eventually it actually comes up. So what that is the fact the superior mirage has actually flipped the image of the sun above the horizon. Even though the sun might still be 2 to 3 degrees below the horizon, it's still being flipped upwards because of that thin layer there. So it's also called a fata morgana. And so that is your superior mirage. And being in Whitby and living that close to the lake, if you're ever walking down there, just keep an eye out for them. Sometimes you can even see ships that get flipped upside down. And so basically you have the regular ship and then the ship that's upside down above it. And it can really lead to some neat adventures that way, in the sense of basically being able to or to be able to see something like that. So the weather is one of those beautiful things where basically you can have it that you can never stop enjoying it, except for maybe if it's a windstorm that tore down your fence. But otherwise, I always call it free entertainment. So yeah, you're welcome now to unmute yourselves, and I believe Sue is going to ask the questions out of the chat. But by all means, if you want to talk on your video as well, but I'm open to that too.
I'll just say that was beautiful.
Oh, thank you, Sue.
Yeah, that was really cool, and to be out in some of that would have been really frightening. Where the cloud was where the sky was just awash with lightning going every which way.
Yeah, what's interesting that when you bring that up is a lot of times there's two types of lightning that I actually myself fear the most, and that is the stratiform lightning because of how far it can reach. It can go along the backside of the storm, and it can actually be so infrequent. Like those super flashes that I have on photos there, sometimes it takes 9 minutes before they would strike again. So you can be easily going outside and go, oh, the storm is over. and then have one drop down near you. For example, some of those photos that you saw were basically, I would see the lightning start on the horizon towards Lake Erie and then plant a cloud to ground lightning strike right in Lake Ontario. So it does give you an idea on the distance of that. And then, of course, the bolt from the blue lightning, where you can see it coming right out of the thunderstorm. As a storm photographer, that is one of the things that is very tricky for me because of the fact that we have to push the envelope a little bit. And that's why they say wait 30 minutes before you go back outside after hearing the last rumble of thunder. But as a storm chaser, if we were to do that, the storm, we'd be zooming in the storm from miles away. You better have a big lens for that type of thing. So it is always tricky. And those are the two types of lightning that I personally fear the most, even though they're all obviously dangerous. It's just the prediction factor. I can't predict it because there's not a real good pattern to it.
Neat.
David, do you regularly provide your coverage to like news and weather stations, or where can we normally see some of your photos?
Okay, yeah, thanks, Janet. Basically, I do provide it to media as well, and usually the Weather Network's the most common one. And but I've been on basically every network except for CHCH, which is kind of funny because they're just down the road from me, and nothing personal between us. It's just that's how it's just been. But it's another way is to my website, davidtchapman.com. And I am also starting to get my YouTube going. So keep an eye on my website because I'm actually doing a neat project right now where I'm doing extreme weather gardening. And that I still have pea plants growing, tomatoes, and things like that. And yet I don't have a greenhouse. I have been covering them at night when it's extremely cold. But I've been doing different projects like that, which I will be doing kind of a vlog series on YouTube with that. And then, so yeah, there's many options that way. But yes, my website would probably be the best for upcoming stuff that way.
Thank you.
No problem. Okay.
There's a, can't tell if that's me echoing. I'm sorry. There is a comment. Really cool talk. The bit about upwards lightning was especially interesting. There was a video on the internet a little while ago with upward lightning from the CN Tower. Really cool phenomenon. I missed that. I didn't see that. That would be cool.
Yeah, that's exactly most of the lightning strikes at the CN Tower that you've seen. Anytime you've seen photos before, that's actually upward lightning. And as I said in the talk there too, it's usually triggered by a cloud to ground lightning strike otherwise. And then within a couple splits of a second there, it basically sends another charge upwards. And so usually in cities, I've seen you get 2 or 3 of those. And that in Toronto, you tend to get one because it's all channeled towards the CN Tower and then goes upward. It's just amazing, though, the fact that you can be in the CN Tower and have that happening and not really know that you just passed a bunch of energy to the sky there and you don't feel a thing because of how grounded it is and safe you are in it. But it's just upward lightning is something that they're still trying to study more. And like I said, with the windmills now, it's not the windmill's fault. It just gives the lightning more channels to go back upwards. And that they're now studying into that aspect as well too. If there ever comes a day that we can harness lightning's energy, it will be a day that will save us a lot of other aspects when it comes to creating our own energy as well too. So
What an amazing, yeah. But yeah, that picture where there was 8 or so going across,
yeah.
To me it looked like a horror film. Right? Like I would say, oh my gosh, that area is bewitched.
Yes.
Right? Like you could see how people would say, I'm not living there. Back in the day.
Yeah, and what's amazing about it is I actually want to be in amongst the windmills sometime to be able to capture it more closer to the source. I may not get as many on video, but I want to get that upward sort right from the source. Well, I won't be outside, I can guarantee you that, but the camera might be outside, or at least I'll be doing the video from the car. A lot of our lightning photos are actually from the from inside the vehicle and that, or at least had the camera outside while we are inside, because we do put our safety first in that aspect. But yeah, that is a goal of ours, basically to capture upward lightning from inside kind of the cluster of windmills and that. So it probably will be hair raising, but it will be neat if captured properly.
Yeah. Are there any amateur storm chasers out there? Any amateur photographers in our group this evening? If you care to comment. There's another couple of comments here. I think the Northern Lights are very cool. Did not know you could see them around here. What is the best time and place to see them near here?
Okay, so what I'm going to do is I'm actually going to type in a couple websites, and that way this will help you kind of forecast or have someone else forecast them for you, until if you decided to get into it more, you could actually start doing your own. And but these are two great websites for getting the information. So what they'll do is they'll write forecasts. They don't do it for Canada, but if you start seeing states like Michigan being mentioned, northern New York, Maine, then generally, obviously, they're kind of south or even with us, then we have a good chance of northern lights as well too. I'm actually going to add another website. So these three websites, if you can't see, if you're not used to this in chat, basically solarham.net is one. Another one is spaceweather.com, and another website, which is just an addition to spaceweather.com, is spaceweatherlive.com. And so you'll get to see a whole bunch of charts that may not mean anything to you at first. What I did is basically self-taught myself by Googling, what does this mean, or checking out websites, what does this mean? And you can decide how deep you want to get into it, because it's still a science that they're still working on the forecasting aspect. So there is nights where you may have heard on the news before, oh, northern lights will be seen all across Canada tonight, and then it's not there. And that's because there's actually 3 steps to the forecasting aspect. And that is, first you need your sunspots, then you need that coronal mass ejection to be pointed towards Earth. And even when it is directly at Earth and interacts with our interplanetary magnetic field, or IMF, it shifts north, and that keeps the particles out of the atmosphere, all those energized plasma and that basically out of the atmosphere. And then we get a very small to little display that they only see up towards the usual northern lights areas, the Arctic basically. So that's why it's still being worked on and fine-tuned, but they are getting better at it each year. And so that is something, those websites, you can at least get an idea that they could possibly come by using those websites. Because like I said, they'll mention New York, Michigan, Wisconsin, that type of thing. And if you start seeing states further south yet, that means likely to be a bigger display. And so that's even better yet. So if you start seeing, Colorado, the North Carolina there, Virginia, that type of thing, then it's likely going to be a bigger show without having to know the numbers and all that as well too. So that's an area where I really hope everyone here has or someday gets a chance to see the northern lights. And like I said, the peak is coming up between 2023, 2027 there, where generally I find 4 years around peak, you do have a good chance of seeing it. I've seen about 175 to 200 displays from Southern Ontario. So I know that we can get a chance for everyone here to enjoy them as well too.
There's a comment where someone said that in London, Ontario, my dad would see the northern lights early in the morning at 4 or 5 a.m. I guess that's why I've never seen them.
Yeah, they can be. Sometimes what happens is you get that coronal mass ejection, and it'll hit at 2 a.m. and then as it charges up the atmosphere, and that you then basically it burst into what's called a substorm, maybe around 4 or 5 a.m. Sometimes though, what I look for is an impact at around 4 or 5 or 6 p.m. because then if everything goes right, it energizes the atmosphere or magnetosphere basically, and you can have a brilliant display at 8, 9 p.m. and that too. So it's really all about that impact time and all about how it interacts with our magnetic field for it to give us a big display. But yeah, it's amazing. I'm glad your dad has got to see them at that time, because 4 to 5 a.m. is pretty early. So he must be an early bird. And but it is neat in that aspect, because I've seen them as early as 7. Actually, before Halloween was, before the time change happened after Halloween, instead it used to happen before, which it makes more sense to do it the way they have now. I actually seen them as early as 5:50 p.m. That was old time, but so that'd be 6:50 p.m. new time now with the way they do it. So that really gives you an idea. You can see them that early. It was a very special display. I was seeing them in late daylight already because of how strong it was, but that was a G5 storm. And people from right downtown Toronto were seeing it. And even as far south as Texas, Mexico even, and Florida were seeing them that night. So it does happen. Those are extremely rare, but they're always ones where, you know, it's worth, if you see anything like a geomagnetic storm 4 or 5, or G4 or G5 is what they'll also call it, then you go, okay, please be clear tonight, because cloud can ruin that too. And if it's clear, you could be in for a great show.
There's a good comment here. It says, early bird catches the storm.
Yes, that is for sure. That is the truth on that as well.
And another question, with snow season upon us, really? When everything else would be, when everything would be pretty much white, any tips on where and how to take interesting photos?
Oh, okay. I find this time of year to actually be a good time of year when the snow does start to fall, to be kind of a wet snow. So what happens is you get a kind of a wet snow, and hopefully it doesn't go too much, because then it causes the trees to droop. But you get this wet snow that coats the trees and coats everything else, and it kind of gives you that winter wonderland in that aspect. So I like this time of year, right? It usually lasts till about middle of December, where those first heavy snowfalls tend to be wetter and kind of stick to the trees, as long as there's not 100-kilometer winds just plastering it to them. But overall, it can lead to a nice kind of winter wonderland. And I usually use rivers, lakes, and other objects that are kind of darker to give kind of a contrast. So it's not necessarily specific areas that I would recommend, but just using things to contrast your pictures, because a wall of white at times can be just kind of overly bright as well too. So but if you're up in an area, I know up in Bancroft there's what's called Eagle's Nest, although a bit hard to access during the winter. But if you can get height too, shooting down as well into it, where you get kind of a valley with different contrasted trees in the distance too, can be quite nice. But utilizing rivers, structures like barns and downtown areas, even, they can all add kind of a really neat winter wonderland atmosphere to it. So this is the time of year I like to kind of shoot my winter scenes as well.
Thank you for that. That made me think of a question. Do you
Sure.
ever shoot, you must, but when the snow is actually falling, and then I guess the flash catches the snowflakes, and then it's all sort of just poof, you lose definition, you don't get a nice shot. You want to get a nice shot of that beautiful falling snow,
Mhm.
but how do you do that?
So during the day, what I will do is I have a fast action mode on my camera. It kind of looks like a Running Man. You can utilize that, and it may not use. It may say there's enough light to not have to use a flash. So that's generally in your daytime. Where it starts to become an issue is when you've got that evening light. Generally, to stop snow, you're going to need some sort of flash, and that because of the fact that our cameras still are, they're getting better, getting closer to that, where they have enough film speed or ISO when in the digital world to be able to freeze it, have enough light around it without using a flash. And so that's where that becomes a tricky thing. Now, something I will do as a trick is I will set my camera at times, put it on a tripod, take the picture with flash, and then have it that my shutter is open longer, so it allows the light from, say, the street scene I'm doing or sidewalk scene to then become balanced out. So then I have my snowflakes frozen, but then I also have the evenly balanced light for the whole entire scene as well too.
Neat. Yeah. Because you want to get beautiful shots when the holiday lights start going outside too.
Sure. Exactly.
Yeah. Any other questions, folks? This has been very interesting for me. I hope everyone enjoyed it. David, you showed pictures of kind of, it was like a layered frost on trees.
Yes.
What did you call that?
So there's different ones that different names for different types. The more caked on version that was really white and that kind of looked layered on was called rime. Actually, it's RIME, rime. And then the other one, I don't know why they have these names. It's not all that flattering for how beautiful it is, but another one is horror frost as well. So
I was wondering because that's what I thought it was called, and I'm like, was it called that in the olden days? I even looked it up on my phone. Because they were just stunning.
Oh.
And when you see that out on a walk, it's just so beautiful.
Yeah, it's nice too. You do live on the north side of Lake Ontario, so it does lend itself to more of those types of scenes. Especially, I'm not used to it in the city, but I'm sure it can happen. But just in your country area, just outside of it, I know it happens there a lot more there than it does here. And we're squeezed between both Lake Erie and Lake Ontario, which tends to cut that out a bit more for us. But I know you would see it a lot more up there.
Right. All right. Well, I'm going to officially wrap it up since we have no more questions. Everyone, thank you so much for coming. David, thank you so much for your presentation. It was fantastic as always. I can't believe you keep getting all this new stuff. But then I guess weather never stops, does it?
That's right. And it was nice tonight to be able to actually share some different aspects that people can actually go out and enjoy themselves without having to worry about them getting stuff blown over or picked up by a tornado or something like that. It's nice to show the fact that, oh yeah, you can see a funnel cloud and it can be on the puffiest little cloud and you don't have to worry about ending up like Wizard of Oz. So all in all, I love this is actually more my favorite program than even my storm chasing show because of that fact that I can share with people something that they can experience as well too.
Yeah. Thank you, David. It was really interesting, not just pictures, but the meteorology. I know it's like a whole nother language.
Yeah, that's kind of why I like to say, for example, when I was talking about the thunderstorm there's thunderhead or cumulonimbus cloud. I've never heard a storm chaser out there call it a cumulonimbus cloud before, and we'd probably all look at him a little funny. He'd be technically right, but it's just something you're not going to yell quickly. So that's why I try to talk in different levels. Same with the altitudes. It's the 850 millibar level, which is the weather term for it, but 1,500 meters level or 5,000 foot level is the way we can actually visualize it, because otherwise it doesn't really mean much. If I wasn't into it, it wouldn't mean much to me otherwise. So I always try to break it down in steps because that's more important to me than having a bunch of technical stuff being spewed onto a screen. I want everyone to be able to connect.
Thanks so much for an excellent and fascinating presentation. Fabulous pictures.
My pleasure. It was great to share with everyone tonight. Thank you for being such a wonderful audience. And I just look forward to being back into the Whitby Library again in the future. And hopefully it's in person, but regardless, this is still a great way to it's a second best thing.
That's right. That's right. On the one hand, we don't have to go outside in the cold. But on the other hand, man, there's something to be said for meeting in person. I hope in a year from now we're back to it. Fingers crossed. All right. Thank you again, everybody.
Thank you.
Have a great night, everyone.